Thank you for those tuning in. I doubt you'd be tuning in because I don't announce these in advance anymore. I just do it on the fly when I'm in the mood. And today I feel like in the mood. And this will be season 2, episode 2 of the Good New World series. And it is entitled New Mathematics. For those that are not aware of it, the Good New World is built on 9 pillars, starting with the Holy Trinity of Trinity, the art, business, and charity. Art being constituted with new life, new mathematics, new commandments. Business, the Trinity of the new business is new exploration, new collective, new governance, and the charity, Holy Trinity, is new humanity, new science, and new religion. So it goes around in cycles. So this is the second season. So we're beginning again with the Holy Trinity of the art. And last week was on, well, not last week, the last episode was on the new life. This is the season 2, episode 2, which is on new mathematics. So bear with me. I'm just going to share my screen of the presentation that we did for tuning in. I doubt you'll be tuning in because I don't announce these in advance anymore. Let me mute that. Apologies, because I'm actually broadcasting this also live onto our collective YouTube channel, and that's why you're listening to a duplicate, but I just silenced that. So let me share the screen with you. Bear with me again. Thank you. Okay. Share. And hopefully this time you will see the full presentation because I did a little technical glitch. The last episode on New Life, I was actually yabbing and the presentation actually wasn't beamed. But I said to you, the information from my mouth is the most important thing. The visualization is there to aid you. So as I mentioned, these podcasts will be based on the same presentation that we're doing. When I say we, I am part of the 3, along with my most amazing and talented and beautiful wife, Andrea Wen, and her mother, Linda Zaraya. So we constitute the 3 member number 5 for the Core 2 Friendship Association. And we do a monthly presentation. And for those presentations, I'm also doing it as part of the Good New World. So I decided to kill multiple birds with the same stone and using the same monthly presentation as for these podcasts. So this month's February presentation is on new mathematics, and that's exactly what I'm going to be using for today's podcast. So, and that is taken for those that are part of the knowledge book, Maulana Supreme Foundation. You can find the exit there, an exit on page 334 of Pascal 22. Our friends, it is a segment is 4-m equals Maulana. So it's an equation, and you'll notice why I picked this because of the number 4. And that section says that Maulana is the representative of the dimension of humanity. Okay, and if you want to check them out, the websites are on the bottom right corner. You can see from there. But anyway, let's dive straight in. So the new mathematics that I personally created is actually a new number theory. Well, it's actually I won't say new, but let's just say I've interpreted it using different concept. And my concept is to divide the natural number into actually 4 dimensions, 4 natural numbers. Now you may ask, well, that's strange. 1 is a 1, right? There's only 1 apple, is that correct? So it's only 1. So why have different natural numbers? But this is where I'm going to explain it. Mathematics is, to me, the reality or the foundation of our realism. Okay, we build like I just said. There's 1 apple, we see 1 apple. By definition, that's 1. There's 2 apples, that's number 2. So the natural, and that's why it's called natural numbers, because originally that's how humanity started. So in the early beginnings of time, when we were still swinging through trees or whatever, we had cognitive ability to count. We will literally count what are the natural numbers. There's 1 zebra out there, 2 gazelles or whatever it is. That's how the natural numbers. So natural numbers is been with us, the human race, for maybe tens, maybe even hundreds of thousands of years. And when we had the ability to start counting animals, objects, etc. So the early beginning of the natural numbers were literally something that we could see and something that we could count. So obviously the 10 number system, the decimal system, is based pretty much because the normal human being has 10 fingers and 10 toes. So I assume that the very earliest humans started counting animal based on their fingers. Oh, there's 1 gazelle here, or there's 2 lions here, etc. So we would literally count. That's why predominantly we use the decimal system, which is the obviously numbers with up to 10. Now, that is the original of the natural numbers, but evolution has evolved, and just as the humans evolve in their technology and on our knowledge base, etc., that's also how our mathematics have evolved with us as well. So the concept, for example, of zero, we take that as granted. Well, yeah, we know what zero is. It's just old, right? But the actual concept of zero only occurred, around 300 BCE during in Babylonian times, where they actually had a symbol. It's actually a cuneiform symbol to represent zero. So the actual concept of the zero and the interpretation of it is pretty much only a few thousand years ago, because before then is pointed like, why do we need to, like I said, we're on the plains of Africa, we don't need to, there's zero gazelle out there. There's no need for that, right? If you don't see any gazelle or zebra or whatever, there's no need to say, oh, I don't see nothing, right? So, but as we got more advanced in architecture, in building, in trade and conformity, then actually the zero comes in handy. But the first symbolism of that was found in Babylonian times around 300 BCE. Europe only actually started using it around the 7th century AD, and that was brought to us, or brought to the Europeans, I should say, by the Arabic time, and they had the zero symbol from India as well, etc. So the zero concept that we take for granted, like I say, is a recent development. And is zero a natural number now? Yes, it's a natural number. It's 0, 1, 2, 3. But what about the minus sign? Again, it's like, can you have minus? I don't see -1 zebra out there. In the early beginning of humanity, there was no need for minus sign. But as we went into, again, accounting for food resources or how much someone owes someone else, then the minus sign became a concept that was useful in our ledger, in our documentation. And I believe the minus sign was actually used, recorded first by the Chinese in 200 BCE. So mathematics has evolved to keep up with what we human needed to interpret the natural world. So now the natural numbers includes the minus sign, includes zero, and of course includes the positive sign. Okay. Now, complex numbers is a recent development, only in the 16th century. So we're talking only about 400 odd years ago, developed by an Italian mathematician. For those that don't know the complex numbers, basically, if you take the square root of 1, it's 1, because if you square 1 is 1, right? But you take the square root of -1. Well, before that, no one knew, well, that's impossible. You can't take the square root of -1. You can't multiply 2 numbers together to get a minus sign, right? So how can there be a -1, right? So, but it comes in useful. And I'm not going to go all the detail where complex numbers are useful, but it was developed where 2 numbers multiplied together gives you a -1. Well, they use the symbol, the letter I. So the letter I is defined as the square root of -1. So that is the interpretation. And why is that handy? You ask yourself, is there a real natural occurrence of -1? Well, actually there is. For example, if you do electrical circuits, I mentioned this previously about my interpretation of my own twin universe, that the negative universe and the positive universe is actually orthogonal to each other. The real universe that we live in, the positive, that we can see and visualize, you can consider that the real axis here, the x-axis, the real axis, and the imaginary, the negative universe, as being the imaginary axis. Now, the two are orthogonal, so they cannot physically see each other, even though they can interact, and the way you sum it is through the vector addition. But again, I'm not going to go into too much detail, but yes, the interpretation of -I, and that interpretation is also realistic, because those that know electrical circuits know that the resistance is a measure of current flow, right? So current flow is resisted through a normal conductor because it heats up the conductor, and that heating the conductor is called resistance. And we actually use that to our use by making a very highly resistive circuit, which heats up enormously, and that heater becomes exactly that, a heater. So what you see as a kilowatt heater is actually just a very lousy conductor, resistor with high resistance, and you flow current through it. That current heats up that resistor, and it glows red hot, and it heats up your room. So it has practical application. But there are two other forms of current impedance to current, and that is created by a capacitor, which is just two polarized plate, positive and negative, and that impedes current flowing through the plate. And similarly, there's an impedance caused by an inductor, a coil of wire, coil. So as the current flows through a coil, it generates a magnetic field. That magnetic field creates a back EMF, which causes a resistance to that current flow. Okay, so those two capacitive are also orthogonal to a real resistance. So those phenomena are real, but you cannot just add those up because those components, like I said to you, the real component you can consider as the positive, the real resistance, just like in my twin universe, our positive universe is the positive x-axis. Well, similarly, in my negative universe, the imaginary axis is the negative universe that's orthogonal to a real. Well, similar in electrical circuit, you can consider the impedance and the capacitance as being orthogonal components as the real resistance. Those phenomena exist, absolutely, and that's why the imaginary concept, the imaginary numbers, is actually a vital component of our new math. Well, so mathematics has evolved. So for those things that, oh no, you can't just develop new mathematics. Well, you can. If our perception of reality changes and a new reality occurs, then why not have new mathematics to describe that reality? So as I mentioned in my twin universe concept, I didn't invent the imaginary component. That's already, like I said, since the 16th century. But that imaginary component is a perfect fit for describing the orthogonal behaviors of a real world and imaginary world, parallel world. Well, similarly, I'm stating that the natural numbers has four components. So in our natural universe, our natural numbers is positive numbers, 1, 2 to infinity, and negative numbers, -1, -2 to minus infinity, and obviously 0 in the middle. So I'm saying those two are the two axes, positive numbers, negative numbers. But now I'm saying because of our twin universe existence, there's also a positive imaginary number and a negative imaginary numbers. And that's why I divided the natural numbers into these 4 dimensions. And those that know my pi-star symbol, which you've seen quite often, that's also representation for life itself. Life itself is coded by the molecular level on the DNA, or for viruses, also on RNA as well. So that is the reason why I developed this new mathematics to help us interpret the reality, the new reality that our cosmos exists as twin universes. So this number is also reflected in perhaps the most elegant and fundamental equation, which is the Euler's formula, which basically you see there. has all the complex numbers, all the numbers that define basically nature. So you said exponential e to the power I theta equal cos theta plus I sine theta. It's also another interpretation that includes the -1 as well. It has all the fundamental or the main fundamental component in the Euler's formula. So again, the four quadrant is based on the four, what I intend the four natural numbers. One is the positive real numbers, so those is 1, 2, 3, or in this case 0, 1, 2, 3 numbers, negative real numbers, positive imaginary numbers, and negative imaginary numbers. So in this case, I've actually, as you see, for the four quadrant, 0 would represent the first natural numbers, which is 0, and on this x-axis. Then you have the positive imaginary numbers. So you go through quadrant 0 to 1, and then you go to 2, and I define that as the negative real numbers, and then the imaginary negative numbers as well. So it goes from 0, 1, 2, 3. So that's the first cycle of the four natural numbers. Then back to the second cycle will be 4, 5, 6, 7, and repeats itself. So that's the four quadrant that I define as the new natural numbers. And this is my natural number nomenclature, my definition of it. So the positive real numbers I define as 4n. So when n is 0, the first real positive number is 0. So when n is 1, the second positive real number is 4, and etc., etc. So 0, 4, 8, 12, 16, etc. Okay, so that's the positive even numbers. And then you have negative even numbers, which is 4n plus 2. So when n is 0, the first negative even number is 2, and then it's 6, 10, etc. And similarly for the imaginary numbers, the first positive odd numbers is 4n plus 1, which gives you the sequence of 1, 5, 9, 13, 17, etc. And then the negative odd numbers is 4n plus 3, giving you the sequence 3, 7, 11, 15, etc. I'm not going to go into too much detail, but I've used these interpretation to solve many complex theories, conjectures, similar to the Goldbach conjecture, which have not been solved for hundreds of years, but using the interpretation, I've come up with a solution for solving the Goldbach conjecture and other conjecture as well. So it has application to mathematical solution and scientific solution as well. So now, we use arithmetic code. You add two numbers, you get another number, etc. So there's typically only one arithmetic for the natural numbers. But because I've subdivided category the natural numbers into four actual number group, I have then interpreted the four arithmetic group with itself. So in this case, for example, you look at this chart. If you add two positive numbers together, n plus and n plus, you will end up with a positive natural number here, n plus. Whereas if you add a negative imaginary number, or a positive imaginary number, ni, on this chart, you see it with a positive real number, n plus, you will end up with ni, a imaginary number as well. So you can see how the addition rules are followed in the arithmetic code for adding the four natural numbers together. Okay, and similarly, develop a multiplicative chart rules, which define how when you multiply any of the four new natural number groups with any of the other four natural number groups, the final result will give you what is. So again, in this case, if you multiply a natural positive number with a natural positive number, you end up with a natural positive number as well. But for example, on this chart, if you multiply a negative imaginary number n minus I with a negative imaginary number, n minus I. You see from this chart, you end up with a positive imaginary number, ni. So again, I'm just giving this. I'm not going to give any examples. They're contained in my published books, etc., and you'll see why they're handy in solving such complex conjectures and problems in mathematics. So again, in real world, we have composite numbers. Composite numbers just basically means two numbers that are multiplied together, the opposite to the prime numbers. The prime numbers are numbers that are unique, cannot be subdivided by any other numbers. The composite numbers are actually a multiplication of prime numbers. So again, normally there's only one composite number, unique composite number, but because I now have four natural number groups, I've also defined, odd composite numbers and even composite numbers. Again, I'm not going to go into too much detail. The equations when interpreting these composite numbers are there. Similarly, for prime numbers, in the natural number group, for positive primes, there's only one unique opposite prime numbers, two being the only even one. Then you have 3, 5, 7, etc. as prime numbers. But again, because of the four natural number group, there's actually now I define as, again, the even prime number. Again, there's only uniquely one even prime number, which is the 2. But the odd prime numbers, there's actually a positive imaginary prime numbers, and there's a negative imaginary prime numbers as well. And again, I'm not going to go into too much detail. The equations are there. And again, I defined the even and odd numbers for this four natural number groups. And again, I'm not going to go into too much detail, and I'm interpreting the even and odd numbers based on these four natural number groups that I have now created. I've also gone to more details, how you can formulate fractions, identities, and inverses for these four natural number groups as well. Again, I'm not going to go into too much details. It gets quite extensive. And if you're interested, then I'll be plugging my book. Go and buy my God book. It's on Amazon. Just search for God or the author, which is me, Leon Ying, and it contains all this information as well. So in conclusion and further exploration, as this final chart will show, is this number theory. We explored the composite numbers, prime numbers, even and odd numbers in the four-dimensional system. Further studies could dive deeper into these concepts, and definitely there's a lot more diving into this and a lot more, I believe, useful applications that will help humanity solve much more complex mathematical problems and provide scientific solutions as well. And similarly with the fractions and identities, they have their uses for the natural numbers. But for these four natural numbers, the uses are going to be absolutely astounding. But I interpret that using the fractional four natural numbers, you can actually solve the Riemann hypothesis, which is one of the most complex mathematics that's remain unsolved in the Clay mathematics. The Clay Institute has offered $1 million to anyone that can solve that problem. So go ahead and use this fraction, and for those smart, will be able to solve that Riemann hypothesis. Go for. So application, this four-dimensional number system could have potential application in fields such as physics, computer science, and cryptography. Further research is needed to explore its practical uses. So, like I said to you, that's the legacy I want to leave, not just on the new science, but on this new mathematics. So thank you again for your patience, for listening in. And again, I want to thank my fellow members of the Quarter Friendship Association, my beautiful, talented wife, Andrea Wen, and her mother, my mother-in-law, Linda Zaraya. And again, thank you to the Quarter Friendship Association for giving me the opportunity to do this monthly presentation, which I am now using also as the material for my monthly podcast in the Good New World series. So let me stop the sharing. So I can go back to you and wish you much peace and love and my Christ our blessing to you all. Thank you.